Hi, my name is Dave Tokic. I'm VP of Marketing and Strategic Partnerships at Algolux, an AI software company delivering the industry's most robust perception and camera optimization technologies. We're headquartered in Montreal with offices in Palo Alto and Munich. And today, I'd like to demonstrate our EOS perception software, which is delivering highly accurate, robust perception for safety critical applications. So why do computer vision systems struggle with challenging scenarios like low light and low contrast? Well, it's really down to three main issues. First, the image signal processor, or the ISP, that takes the raw sensor data and converts it into something for display that's visually pleasing, is actually designed by humans and tuned for humans for human consumption. And that's not ideal for computer vision algorithms. In addition, both the imaging teams that are working on the camera and the perception teams that are working on the computer vision algorithms really independently optimize, and they don't co-optimize these two domains. And lastly, the training data sets that are used for these perception models are typically using open source data sets or data sets that are captured from prior generations of cameras that aren't the actual camera that's being used for your next design or production design. And they're also typically biased towards good lighting conditions because those are easier to capture and annotate. So they're not ideal for the scenarios as well. Algolux takes a very different approach, and we've architected EOS as an end-to-end network that combines both the image processing with the detection together. This bypasses the ISP, taking in raw data, and allows us to easily adapt to any lens sensor combination. And our training process actually applies different unsupervised and adaptive learning techniques to handle these different camera configurations. But this results in both very high, robust, accurate performance, as well as massively reducing the amount of data that you need to capture and annotate. EOS supports the full stack of perception tasks and is easily adapted to support any image sensor, and also supports radar and LiDAR sensing modalities as well. We also are agnostic to the processor and can support the processor of choice for your particular design. Now let's go into EOS really being used in real world scenarios and also show some comparative benchmarks against other alternatives in the market. So let's start with some automotive use cases in pretty harsh conditions: low light, snowfall, fog, rain. And also you'll notice that EOS is showing very high accuracy under these challenging scenarios, but you'll notice that the bottom left example here has a much wider field of view and is actually an RCCB color filter array versus the RGB for the rest. EOS was easily adapted to and quickly adapted to support that scenario. Here we show 3D object detection of various classes. And in addition to that, we're able to produce a bird's eye view of that data, as you can see on the left there. Moving on actually to a really challenging scenario of traffic light state detection under difficult lighting and adverse weather and conditions here. This is a big challenge for both ADAS and AV companies out there today. And you can see we do an excellent job of properly detecting the light state, even at distance. Now we'll switch gears to show some very wide angle fisheye type applications where the lens on the left, for example, is quite dirty and challenging, and in dark scenarios on the right. You'll notice that EOS is doing a very accurate job of detecting these object classes, even through the distortions at the edge of the lens there. This shows actually similarly a surround view parking application doing both object detection and also free space for the application, both outdoor and indoor scenarios. Now let's move on to some smart city application. And here's Not an uncommon scenario where the installed camera had an out of focus lens, and even so, EOS was able to detect quite well through that. Here are some indoor pedestrian safety. Again, low light, low contrast scenarios where we're significantly outperforming the commercial alternative. And here's another example of the same, but in an outdoor scenario with low light and very noisy images here. Again, EOS with very high detection accuracy. Moving back to automotive, here's an example of EOS being compared to Tesla. In this scenario, we're actually at a pretty significant disadvantage because while we're doing only frame-by-frame, camera-only detections, Tesla is actually doing camera plus radar fusion and tracking. And even so, we're significantly outperforming them, especially at objects at distance that are quite small. Showing a different comparison, here is the EOS object detection comparison with Nvidia Driveworks under very difficult conditions here with this very dirty windscreen, as well as very challenging glare conditions. And as you can see, EOS is significantly outperforming Driveworks under these really challenging conditions. Looking at it more objectively, here's a comparison of two different data sets. So one under clear day, good imaging conditions, as well as under low light, nighttime conditions. And in both cases, EOS is outperforming Drivenet by 2x MAP, or mean average precision points. And with that, I want to say thank you. And if you want to learn more, please visit algolux.com or contact us. Thank you very much. Bye now.